has been using Ruby and Rails since 2005. He enjoys, that does deserve some whistles. I like that. He enjoys writing concise, readable code, especially in Ruby. He enjoys a player coach role, helping teams improve their processes, technical practices, and automation. He's likely looking for work right now. Giving a conference talk is Craig's way to strike up some conversations, so feel free to go up to him and talk shop during lunch afterwards, maybe even offer to buy him lunch. If you want to make small talk, ask Craig about traveling, attending concerts, beekeeping, or where he was when the pandemic hit. Craig is giving a talk on nothing, so let's give it up for Craig Buchek.
All right, hi, I'm Craig. I'm going to talk about nil, its pitfalls, how to avoid them. If you want to add me, my Twitter's on the screen. Also Ruby Social, I'm rarely on them, but feel free to add me. I have a short URL for the slides. You can actually follow along. I just committed them, so they should be up to date. Something just popped up on my screen. If you want to follow along, if you want to look at them later, I do have presenter notes that have some links to resources and details that I don't have time to cover today. So hit P for presenter notes if you want to follow along. Show of hands, who spent time debugging problems with nil? All right. How much time do you think this cost you in time and money? A lot? Yes. Blocking my screen. So it's cost our industry billions of dollars, in fact. So Tony Hoare invented the null reference in 1965. He also invented the quicksort algorithm. He won the Turing Award in 1980, which is basically the Nobel Prize in computer science. So this is a quote from him in 2009. I call it my billion-dollar mistake, the invention of the null reference. He also said, I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. So we're stuck with that situation, right? So I'm going to start with the basics, show some problems with nil, talk about why we run into these problems. We'll look at alternatives and then wrap it up. So I hope you're ready for some code. There's going to be a lot of code. This is about the end of my interesting pictures on slides. So nil is pretty simple, right? Use it when no other value is valid. Like all objects in Ruby, nil has a class. It's called nil class in this case. In fact, there's only one instance of nil class. No matter how we get nil, it's always the same object. Here we've got two objects. We call nil two times. We set it to two variables. They're the same object because they have the same object ID. We call that a singleton, even though it's not actually using the Ruby singleton module. It's like a special case in the interpreter. That number 4, it's always going to be 4. And the only other things that are like that I know of are true and false, which are 2 and 0 for some reason. You can't even create a new instance of nil class. So where does nil come from? How do we end up with nils? Instance variables are nil if they're not defined. But local variables raise a name error if they're not defined. So we don't get a nil there unless we're explicitly or get it some other way. Note that exception message. Ruby treats local variables and method calls the same. It doesn't know until runtime which it is. So that's kind of interesting. I'll often refactor to extract a variable to a method. It's a lot more flexible for me, and you don't have to think about it, how the details of the implementation, unless you need to go look at it. We'll often get a nil without expecting it. If there's no value returned specified in a return statement, it'll return nil. Using a bare return like this in a guard clause is a pretty common idiom in Ruby. An empty method will return nil. It's kind of like the default value, right? If you have an if without an else, this will return nil. Implicit returns are probably the most common way to get a nil. A method will always return the value of the last expression if you don't have explicit return. And puts method always returns nil. And so here the error bang method will also return nil. In general, if a method doesn't have an explicit return value, expect that it might return nil. So how does nil behave? So nil class is a direct descendant of the object class. Most classes in Ruby inherit from object. The kernel and basic object are beyond the scope of this talk. But they're interesting. I actually have notes in the presenter notes if you want to read a little more about that. Nil class adds only a few methods of its own. Most of these are for coercion to other types. And then there's a few for logical operations, so nil can be used as false or in place of false in a lot of cases. I'll talk about that in a bit. That last one is the pattern matching operator. That's a really weird case, and it's like for one specific reason, so don't know why. Converting nil to various types results in an empty or a zero-like value. Also, if you run inspect, if you do pretty print or you're seeing the result in I or B, you'll see the word nil printed. So you end up with an empty string or an empty array or 0 or 0.0, whatever. So the nil predicate method returns true if your value is nil and false for everything else. So nil question mark, there's a couple different ways that we pronounce that. We can call that the predicate method. A predicate method just means it returns true or false, or truthy or falsely. We'll get to that. Nil question mark, nil query. I like the Canadian convention, which is nil A. And I've also heard nil, huh? All right. We often use nil A to check for nil, but we can also use the falsiness of nil. The Ruby convention is actually used to use that latter form. It puts the positive or the happy path case first. The only caveat on that one is if V could be false, that could also, fall into that else. You want to treat false differently from nil. It's rare to have a method that could return false or nil or something else. And if you do, just don't do that. It's a huge code smell, and it's just going to cause problems for sure. But in a guard clause, both of these are equally common styles. I normally prefer to be explicit in intention revealing, but I don't really have a preference on this one specifically. So this is how Rubinius, which is like an alternate implementation of Ruby, implements the nil predicate method. It's pretty straightforward object-oriented programming. It doesn't take much to understand that, right? So I talked about falsiness. Ruby treats false and nil as falsy. So anywhere you've got an if or anything that needs a Boolean value, if you've got nil, that'll work as false. Everything else works as true. Nil and false, act as false, everything else is true. Even zeros and empty collection are true in Ruby. That is not the case in several other languages. I know Python, I believe, treats the empty array as false. So that can cause problems on its own. So we only have two values to worry about being falsy, so that's nice. Nil and false are not equivalent, though. They're only equivalent used in a Boolean context or a Boolean test. Unlike truthy and falsy, there's no nillish concept in Ruby. You might come across those terms, truthy and falsy, in some RSpec tests. Expect nil to be falsy, expect nil not to be truthy. So Rails adds a few other methods like blank and present. Blank is true if the object is nil, if it's empty, or it's a string with only white space. And present is basically the opposite of blank. Just put a not and you'll not present and it will be the same as blank. These are not in standard Ruby. They're in the active support gem. And I tried to require active support, and actually that didn't work either. So you have to do require active support all. There's another way to get just that specifically if you want to. These are great for handling input. They treat blank input the same as missing input, which is usually what you want to do. Rails does that by default. So if you put in put some spaces in a blank text box, it's kind of treated the same as if you left that empty. So because Ruby instance variables default to nil and nil is falsy, we can use the conditional assignment operator to initialize an instance variable, to set it if it hasn't been set yet. The caveat here is if it was already set to false or already set to nil explicitly, this will not work. It will override that original value. But in most cases, we don't have to worry about that. And if you end up getting a nil and you replace it with a nil, that's usually not a big deal. So this is a common idiom in Ruby to memorize a value. So we only have to calculate that result one time, and then we store it away. So the next time it'll actually return intermediate result. Well, I guess the conditional assignment operator returns the value. At that point, it's actually the value of either side. So nil can cause us a lot of headaches, right? It's idiomatic to use nil as a default value for optional parameters. Here we're using that conditional assignment operator again. And this probably isn't the best example. I see it a lot, but we probably should have just used name equals guess in the parameter list. Passing nil is not the same as not passing an argument, though. So nil isn't actually special here. It's just a valid value for the parameter. So here D does not get assigned the default value. However, we tend to use this idiom a lot. In this case, passing nil does have the same result as not supplying the argument. Hopefully you can see the difference there. It's because D was nil by default, and if we pass nil, it's going to use that same thing. So here's the main problem. Nil only has a few methods defined. I showed you the ones that it defines itself, but I believe object has like 75 methods or so, which sounds like a lot, but remember, an active record object is like 700 or 800 at this point. If you try to call any other methods, you get no method error. There's nothing particularly special about nil in this case in regards to no method error. It happens anytime you tell any object to do something it doesn't know how to do. The biggest problem I find with no method error is the exceptions raised usually nowhere near where you set that value. So you're like, how did this get to nil? And you gotta trace back, like trace all your steps back. I guess a backtrace is pretty useful for that. But even that, like you've got to go to each frame in that backtrace and try to figure it out. So other languages have similar exceptions with similar names. Note that all of these languages are pretty much dynamically typed. In statically typed languages, we can catch most of those errors at compile time. If you're using something like sorbet, it will generally catch those at compile time. If you've ever used Crystal, which is a compiled language that's very Ruby-like, it does a good job at compile time and making sure that you've covered the nil case, which is pretty awesome, actually. One of the reasons I put this slide up here is Java programmers kind of assume that everyone's a Java programmer, and they'll just say, oh, I got an NPE, and you're like, well, what's an NPE? Oh yeah, null pointer exception, okay. The interesting thing is C will give you a segmentation fault if you try to dereference the null, and that's actually the CPU saying I can't reference that address. Before we get into solutions, we should understand what's causing these problems. The problem rooted it all is that nil has many different meanings. It's used for a lot of different reasons. We need to understand what nil means in each context so that we can replace it or fix it with a more meaningful value. So how we fix nil depends a lot on the context. I talked about unset instance variables. We pretty much just have to deal with that one. We get the nil, we deal with it. A lot of times we'll use nil to mean empty. I've got an easy fix for that one. That's usually pretty easy. If nil represents a missing value, we might replace it with an empty string or an empty array. If you're using it for not supported, most likely you should probably be using a not implemented error instead of nil, depending on how you want to handle that. A signal value is a special value that indicates something special. Back in the Y2K day, remember they were using 4-digit dates, I guess 6-digit dates. So month, year, or day, month, year, so just a 2-digit year. So a lot of times you see 999999. That was a sentinel value for like an invalid date. So a little bit weird. So if we use nil as a sentinel value, we're probably not going to use 999999, we might just replace it with a symbol. If nil is used as a default value, probably just use the actual default value that it should be. So Ruby uses duck typing. If it walks like a duck, quacks like a duck, it's probably a duck or close enough. We don't care what an object is. We only care what it does or what it can do. In object-oriented programming, we rarely ask about the type of an object. In fact, that's a code smell. We just try using it. This makes Ruby very dynamic. A lot happens at runtime, which means you get a lot of runtime errors instead of compile time errors. Pretty much any value you have could be nil. So we want to do everything we can to avoid the problems with nil. In this case, I've got an animal. It might be a dog, might be a cat, might be nil. So I don't know if animal speak is going to woof, if it's going to meow, or if it's going to raise an exception. So that's a big problem, right? So how do we solve those problems? More importantly, how do we solve the problems without causing other problems? So there's two basic strategies: handle it or replace it. So we'll start with handling it. So you can't always get rid of nil so easily. So we do a nil check. We check before calling the method on it. So if it's nil, we do one thing, and if it's not, oh, that's an unless there. I was like, what? That's all right. Yeah, so first case on line 3, unless user is nil, we know that the user is probably a user. Otherwise, we can raise an exception or print some other message. So the first example is a little more explicit. It's more clear that we're checking for nil. But the second example is more idiomatic, more concise, more readable to most Rubyists. The community standards prefer if over unless, because unless is a lot of times harder to read if you've got a unless else, like never use unless else. It's like double negatives. So we can think of if user as if there is a user, as opposed to unless there is not a user, and that gets confusing. The second example will also raise an exception if user is false. I talked about that problem of, don't have things that return false and nil. All right, these are less idiomatic, readable versions. It's idiomatic to put the positive case first when using an if-else, like talk readability, understandability. So the ternary operator is that question mark colon. It's often a good choice if you're doing a nil check here, when the positive and negative cases are simple enough to fit on one line. My rule for ternary is if it doesn't fit on one line, it's not a ternary. It's too hard to read across multiple lines. A guard clause is usually the best situation for a simple nil check. Oddly, in the clause here, we have to cover the negative case first, because we don't want to do anything interesting in that case. We just want to bail out. There's no strong community preference between these first two, because there's no double negative like unless user nil. And they're both pretty easy to read and understand. The third option is appropriate if the exception is the right response. But nil checks lead to a lot of bugs. It's easy to miss edge cases. They add a lot of error handling code that kind of gets in the way of understanding what's supposed to be happening in the happy path. But there's a better way. This is not it. This looks like a nice solution, right? It's not. Don't do this. This will rescue any exception, not just the no method error. And the problem with that is you should never rescue an exception you aren't expecting, because you'll end up hiding bugs from yourself, hiding exceptions from yourself, and then you're like, what is going on? Why is this happening? You'll have hours of fun, I guarantee you. Ruby 2.3 introduced the safe navigation operator. It's an ampersand and a period, also known as the lonely operator. Mutt says it looks like a person standing alone looking around for someone to talk to. And I have a hard time remembering, is it ampersand period or period ampersand? The ampersand is a person looking at the period. So that's how I remember. And in JavaScript, most other languages, it's question mark period. Although I think there's a language that's question mark, and one that was period question mark. So that's confusing if you're switching between languages. So the lonely operator effectively replaces a chain of growing ands. It's the logical and. Don't forget to use the safe navigation operator on each level of the chain. It only skips one call, not the whole chain. So Rails Active Support has had the try method even before we had the safe navigation operator. It's a little bit different. There's actually try bang, which is actually the same functionally. But try by itself doesn't respond to instead of checking for nil. So it'll handle any no method error, even if it's not on a nil. So try is slightly different. Oh, oops. If the receiver is false, the safe navigation operator will return false. So this could return false, or it could turn nil in some cases. Here's an example that provides a default value. So at the end there, this string of calls, if it evaluates to nil, if it doesn't evaluate to nil on line 7, it prints the answer. But if it does evaluate to nil, we can always replace it with a default there. So that's it for handling nil. Now let's look at replacing nil. In the case where we use nil as a default value for parameter, we were using nil as a sentinel value to indicate that we didn't provide that. So we can place that with any value, really, any value that we're not using. One of the suggestions I've seen, I think Avdi is the first person I saw it from, maybe the one that suggested it first, use a symbol there. And if you end up with an error, if you try calling something on not provided, you know it's not provided, and you can go search your code for not provided symbol. So an empty array doesn't do anything when you iterate over it, right? In a lot of cases, this is exactly what we're looking for. So consider returning arrays instead of single objects or nil. It's a pretty common practice in Ruby. It's readable. It's idiomatic. So I first learned about this in jQuery in 2007. It's a different way of thinking about results. So jQuery is about finding things on a web page and modifying them. And at first you think, well, let's just find the thing and change it. But if you think about, well, let's just find all the things that match that pattern and change any of them or none of them if we don't get any. But you don't always have control of what a method will return. So in Rails, I like to use array wrap to ensure you always have an array. And this will convert a nil to an empty array. Also, if you already have an empty array, well, if you have any array, it'll just pass that array as is. And if you have a single value, it'll wrap that in an array as well. And now you can treat that as a collection and work on the collection instead of any individual things. So Ruby actually has an array top-level method. I prefer to be more explicit with array wrap. This looks like an initializer to me. If you're Python, you don't need the .new or whatever it's called in Python. So that's always a little confusing. And there's also a weird thing in Ruby. So this array method is in a separate namespace than the array class. Very confusing, scary. So if you've got an array with some nils in it and you need to handle each of the things in the array, get rid of the nils. You almost never want to deal with those nils in any reasonable way. So you can call the compact on an array and it'll get rid of all the nils for you. So Ruby 3.1 actually added compact to enumerable, so it should work on virtually any type of collection. So in Ruby 2.3, they added dig. I love dig. It's used to navigate nested arrays and hashes. These two lines are actually equivalent, except the dig method won't raise an exception if there's nil anywhere in the chain. It'll just return nil in that case. All right, so result types. Sometimes we want to wrap a result in some sort of object to basically make it easier for us to determine if that result was a good result or if it was a failure, if it's success or failure. So this is a gem called resonad, which is result monad, I think. And if we have a success, we can get the value of the result. But we can't get the error message because there is none. There's also a gem called dry monads. I thought this was better for examples than that, though. That all seems pretty straightforward. If we have a failure, we can get the error message, but we can't get the value. So failure we'll often use that in a rescue clause because there's an exception and we want to, in the exceptional case, we don't want to like propagate that exception. We just want to say, oh, well, I didn't get a result. Here's your error message. So this result type, you can deal with that result in a couple different ways that may be simpler or at least chainable. So in the first example, we add 1 to the value. We're using map. It works similarly, except you only have 1 value instead of multiple, or you might have 0 values. So in this case, if we're dividing, if we have 5 and it's a success, then we add 1 and we get 6. Second example, we add 2 to the value, and we can use that value in the on success block because divide 10 by 2 is successful. It will skip the on failure block. And then it'll actually return that success object so you can keep chaining these along. Uh-oh. Oh, all right. All right. All right, in the divide by 0 example, because we have a failure, the on success block is skipped, and we log the error in that on failure block. But we return the failure object. So it's not great for returning things unless you explicitly unwrap. So results objects are a good solution if an operation can fail in multiple different ways, and you've got a series of operations chained together, and it can fail at any place. There's actually even a way, if you have a failure, to turn it back into a success and then keep the chain going. The option type is similar. Instead of a success or failure, it can contain a value or no value. Pretty similar, except they just have a slightly different meaning. This is also sometimes called maybe. And the option type makes it clear, you may or may not have a value. When you see that option type, you can say, option sum, you're like, okay, I've got an option, name is an option, an empty name is an option. I know that those could be nil. I need to be very careful about those. See. So this is a common pattern in statically typed languages, especially functional programming languages. All right, here's the null object pattern. And this, in a lot of cases, is an excellent solution, the one we're going to focus on. So the null object pattern uses object-oriented programming to solve this problem. Instead of nil, we use an object, and that object responds to the same methods as objects that the class is associated with. In this case, the user class. Calling the methods on the null object results in the default value, default behavior, or degenerate behavior, or whatever that nullish behavior is. We can actually be very explicit about it. And notice that this null object has the same API as the original object, but behaves differently. That's kind of the gist of that. It's best if you have the callee return the null object instead of the caller. Don't let the caller get that nil, so they'd never have to deal with it. This is a principle called make impossible states impossible, or unrepresentable. My notes have a pretty good article on this and a really good talk on this by a friend of mine. So I want to share this pattern. When you write up a talk, you learn new things. This is one of the things I learned. It's the black hole null object pattern. I'm not sure if I can recommend it because it's another thing that hides bugs, and has a potential for unexpected behavior. It's definitely interesting. So we got here. I made it a singleton, so there's one black hole, and you can call any method on it, and it'll just return itself. And you're like, okay, that's great. I can keep doing that, but like, what if I need something specific there at the end, or I needed to do something? I need to be active, or I'm trying to, what if I'm trying to serialize that object? Like, I'm not sure what's gonna happen. So Avi Grimm created a gem called Naught. It supports a lot of options, including the black hole null. It's really a toolkit to build null objects. It's got tons of options. It's got great traceability. It solves a lot of problems. It doesn't look like it's been maintained a whole lot since he wrote it, but it is very thorough. So if you're considering creating a null object class, maybe use that as a base class. So here, the example, I've got a null log. So it's a singleton, so I call null log.instance instead of new. And in this case, the mimic example log will, I believe it only implements the same methods that the log object implements. So it reduces that surface area of what it'll deal with. So the null object pattern is a special case of the special case pattern. So that less than is like in Ruby, a subclass is less than a superclass. So special case is kind of a superclass of null object pattern. A null object is basically the special case pattern applied specifically to the absence of objects. And that line can get kind of fuzzy, like is a null object a null logger? Is it a null object or just a special case? Like that null logging isn't really dealing with nulls as much as just providing a default behavior. So special case classes handle a lot of special conditions and edge cases. They can use to handle special cases that don't fit the null object pattern, like dummy objects. So if you've got a test and you don't want to deal with like the actual object, maybe that's on a database, you could create this little dummy object and have the same API and test with that instead. This is also called exceptional case. If you've heard of the strategy pattern, this is kind of related and in some ways a refinement of that design pattern. So special cases can be really simple. The key is that we use polymorphism to handle that special case. We create a new class that responds to the same methods as the original class. It could be a completely different class, or it could be a subclass, as we have here. And we just implement all the same pertinent methods. This is a pretty standard example. If you're a regular user, you can only access your own resources, but if you're a super user, you can access anyone's. This is a special case that is not a null object. So programmers have a tendency to reach for language primitives, even when there's a better solution using the language features. So an example is if you've got money, a lot of people will reach for a floating point. That's not the right answer in that case. You want something richer and also more accurate. Or using a string to represent a URL. If you use the URL object, which or class that comes in Ruby, you don't have to parse it. It's already parsed for you. You can get, is it HTTP or is it HTTPS? What port is it on? What's my path? What's the web server am I hitting? So use something richer instead of a primitive if you can. So objects allow us to have a more consistent API, more methods, adding some constraints and validations. In Ruby, it's usually strings that we're going to treat in this way. We call that stringly typed as a joke, a play on the strongly typed languages. Our examples overuse nil a lot. Technically, everything in Ruby is an object. Nil is an object, second slide. But I'm talking about a more rich object, a custom object here, a custom class that has that larger API. Remember this from the Rubidius slide? This is also an example of a special case pattern. Barely even feels like a pattern, right? We like to think of their patterns are special, or we should choose the patterns, but a lot of times it's just a way of explaining what we're already doing. Here it's just using polymorphic classes that have the same interface. So specialization is really what object-oriented programming is about. We want to, a good way is eliminating conditionals. If you can eliminate conditionals and use polymorphism, you're doing OOP right. Or isolate those conditionals in one place, often a factoring method, usually like as early in the process as possible. Eliminate your nils as early in the process. Take care of all those special cases early in the process. So there's more than nil than meets the eye. There's a lot of nuance. It's not always simple. It's usually not the best choice. It's usually better to replace it than handling it. OOP is our friend. It's primarily about encapsulation and polymorphism. If you ever interview with me and I ask you what OOP is, please use both of those words. So polymorphism allows us to treat all objects the same way without having to type check. And so we just use polymorphism instead of conditionals. Think in terms of the messages you can send to objects. And let the objects do their job. They know how to do their job. Let them do their job. Lean into object-oriented programming and polymorphism. These are powerful tools for using Ruby well. So I was thinking about what are some other billion-dollar mistakes in the programming world. I think these would probably hit the billion-dollar mark. The one I've been harping on for a long time is implicit coercion to Booleans, like I talked about in Python. Zero and empty array could be false, and you're like, how did that happen? So that's probably, in my opinion, that's probably the second most expensive mistake in programming language design. We don't have like the falsy with nil. That works well, but when you added one more, it just seems to break for me. SQL injection, sanitize your input. That's a very costly mistake if you don't sanitize all your inputs. So C string libraries, it's a case of not sanitizing your inputs, not checking to see that your buffers are the right size. The string libraries are just like, that string could be any size, and we'll just let you keep writing as long as you want. So there's no bounds checking. So that's, I believe, a lot of the original viruses on the internet are because of buffer overflows. Bad cryptographic hygiene, like things like not encrypting your passwords in your database, or using a fast hashing algorithm to encrypt your passwords in your database. If you're trying to keep those passwords secure, you want to slow down the attackers. You don't want to have them run billions of times a second. You want them to maybe run one check a second. And you can do that with slow hashing algorithms. And time zones, right? Everyone had problems with time zones. Spent a lot of time debugging time zones. Having problems that happen every 4 years sometimes. Okay, so if you want to dig more into the null object pattern, Sandy's talk is amazing. It's called Nothing to Something. It digs a lot more deeper into a lot of those. She does cover like getting rid of if statements and conditionals a lot. Avdi's got a talk and a book. They're great. They show how to use the null object pattern within a larger context. David Copeland, I didn't see this one until I was working on this talk. Eliminating branching, middle, and attributes in his Ruby code. And in some ways, they lead to better code. There's a couple of really good sites on design patterns. Source making is one of the best. It's also really good for refactoring and anti-patterns. And if you look at the presenter notes, each slide has, a lot of slides have some more resources. So I am currently wrapping up a short-term contract. I'm looking for my next great opportunity. I'm easy to find on the internet. Thank you for coming.